This lesson is dedicated to the other four primitive data types. We will start with the category of floating point numbers, float and double. These types are also called real numbers or fractional numbers. The main difference between them is the same as the types of the integer category have. Float type requires less space, that is 4 bytes, and it allows a lesser range of valid values. Double type requires more space and allows a larger range of valid values. All that you should understand about these types is that when you need to use fractional numbers, make use of one of them. If the result must be more accurate in several characters after the dot, use double type. It means double accuracy. If the accuracy is needed in no more than 1 or 2 characters after the dot, use float type. You can use them just like int type. Let's solve a small problem which shows how these data types are used. We need to write a program. When you put a radius of a circle into it, it will calculate the area of a circle and display it. So let's IntelliJ IDEA, create a new project, float double. Create a new class, call it area. In this class, we will calculate the area of a circle. Create a program entry point. To calculate the area of a circle, use this formula. Area equals pi multiplied by r squared, which means pi multiplied by radius and again by radius. Thus, we will need 3 variables. The first one will store the radius. Let's create it. Let it be double r semicolon. The second one will be called pi. It will store the value of pi. Double pi equals 3.14 semicolon. And the last variable is for the area. Let's assign a value to the radius. Let the radius be not integer. For example, 10.8. Now let's assign our formula to variable a, area. It will be pi multiplied by r and multiplied by r again. Let's print this value on the console. Type the text comment, the area of the circle equals, and add our variable a. Run the code and see the result. The area of the circle equals 366 and a lot of characters after the point. Now let's recast all these double types to float types. When we create a fractional variable, it will automatically be of the double type. To cast the float type, add letter F at the end. We are doing the same with variable pi. The area will be a float type too. But we don't need to cast this type because we are using float type globally, so the result will be automatically converted to float. Run the code once again, and you will see that the value of this area is not such a long number. That was all about the floating point numbers for today. It's all quite simple and similar to int. At home, you will write a program which will accept the values of the legs of a right-angled triangle from the user input, and then apply the Pythagorean theorem to calculate the length of its hypotenuse. This is not a simple task, I would say, but I believe you'll be able to handle it. The only thing we haven't studied yet that is required to complete this task is calculating the square root of a number. I will show you how to do this, but this might be hard because we're going to learn methods later. There are built-in methods in a standard Java package that were written by other programmers. One of these methods is written as follows: math.sqrt, and between the round brackets, write the number the square root of which is to be obtained. This method returns the square root of this number. For instance, let's put in 36. We all know that the square root of 36 is 6. So let's assign this value to a variable double sqrt. Let's display the value. Square root of 36 equals sqrt. Run the code and we will see square root of 36 equals 6. So when you want to find the square root of a number, use the method of class math.sqrt, and put this number between round brackets. That's all for the homework assignment. Should you have any difficulty, you will find the solution attached to the next lesson. Let's now continue with data types. We still have two more types. One is char, which is a character data type. In fact, according to the official Java documentation, char is considered to be an integer type. But since this type is designed for working with characters, we have placed it into a separate group. There is a table of ASCII characters. If you want to see it, look it up on the internet. In this table, every character has a corresponding number. Thus, character X corresponds to 88. So let's get to writing the code of a program. Get to the code, create a new class, call it char. As usual, we will create a program entry point. Now let's create a variable of the type char. Write char, call it ch1, and assign it the value of 88. There are two ways of assigning a value to a char variable. The first one is to use the character code from ASCII table. Now create a second char variable, call it ch2, and assign it a value using the second method. To do that, write the needed character in single quotes, type single quotes, and between them specify the character. Let it be character Y. Don't forget about the semicolon. Here we have assigned the same value to two different variables using two different ways, because 88 is the code of character Y. Let's print out both variables on the console and make sure. Type ch1 and ch2. Run the code. As you can see, I have made a mistake. The character code for Y is not 88, but 89. Now we have assigned the same value to both radius. Since char is an integer data type, it can be manipulated like a number. Let's increase the value of ch1 by 1. Type ch1 plus equals 1 semicolon. Run the code. You can see that now the value of variable ch is z. And the last primitive data type to be studied is boolean type. It is a logical data type which can take on a value of either true or false. They are the values which are returned by the comparison operations. If you remember in our lesson about conditional operator if, we wrote, if A is more than B, do this or that. So in this operation, there is nothing else but a Boolean value. Let's get back to the example with the air conditioner. If the temperature exceeds 25, turn the air conditioner on. Create a new class, call it bool, and create a program entry point. Create a variable, call it temp. Assign it the value of 26. And type the following. If the temperature exceeds 25, print out the message "the AC is on." Let's run the code and make sure everything works. Our message is printed out. The AC is on. Let's now create a boolean variable which will store the temperature condition, either hot or not hot. Create a variable by typing boolean hot and assign the value that the temperature is higher than 25. It means that when the program checks if the temperature exceeds 25 and the temperature is 26, the value will be true, and this value will be assigned to the variable hot. This allows us to point to this variable in the instruction of checking the condition. If it's hot, turn on the air conditioner. Let's run the code. It works just like it worked before, and we can see the message, "The AC is on." If we want an action to be performed unless the condition applies, which means that the variable will be equal to false, we should place an exclamation mark before the variable. For example, we want to turn off the conditioner when it's not hot in the room. Put an exclamation mark before the variable. If it's not hot, the air conditioner is off. Let's assign the value of 20 to a variable temp and run the program. The AC is off. It means that the code will be run only when the condition applies. The comparison operations we have used are only more or less. In fact, there are 6 of them. They are less or equals, more or equals, equals. Thus, we check if some variables are equal to each other. Beginners often make a mistake at this point. When they need to compare 2 numbers, they write if temp equals 25, and then they wonder why they would encounter a mistake. The problem is that the symbol equals in programming means a sign. In order to compare 2 numbers, 2 equals symbols are required, and when 2 variables differ, there must be an exclamation mark and the equals mark. Before practicing, let's learn some more theory. A condition verification can contain any number of conditions. To do that, logical operators and or are used. For instance, we want to turn the air conditioner off if the temperature is lower than 25, or if the time is more than 23. That is, if we don't want the air conditioner to work at night. Then we can create an additional variable. Let's create variable time, which will store the time and assign it a value of 24. We will also create another boolean variable. Call it late and assign it a value that time is either more or equals 23. Now we can add another condition. Now the air conditioner is turned off when it's not hot. Let's add the condition that it will also turn off when it's late. Type or, it's written so, late. In this case, the air conditioner will turn off if the air is not hot or it's late. Let's set the temperature to 40 degrees, which means that it's hot in the room. Let's once again specify the condition that it's hot if the temperature exceeds 25. Run the program and we can see the AC is off. Although it's hot in the room, the air conditioner will not start because it's already late. If we use symbol or, the action will be performed if at least one of these conditions applies. In order to have the action performed, only if both conditions apply, that is, the air conditioner is to be switched off only if it's both late and not hot in the room, operator AND is to be used. Ampersand stand for and. Let's run the code. As you can see, no messages is displayed because it's already late and this value is true. But at the same time, it is hot in the room, which means that the condition is not hot in the room is false. Thus, the action block is skipped. To have it run, two conditions must apply. Let's make the temperature to 22 degrees and run the program. This time, the message is displayed because it's both not hot in the room and it's late. You have already got a homework assignment on the topic of fractional numbers, so we will solve a problem on logical operations together. Should you wish so, you can pause the playback and try to do the task on your own. So the task is the following. Write a program which advises what you should do depending on the time of the day and the weather. If it's late, which means that the time is more than 23 and less than 5, the program will display a message sleep. If it's not late and the weather is fine, the program will print go for a walk. If it's not late and it's raining, the program will advise to read a book. All conditions must be stated within separate variables, and you cannot use else operator this time. It's not that using else is some kind of bad practice, but you should learn how to combine various conditions. Using else will simplify the task. Now I will allow you to some time to pause the playback and do the task on your own. Good luck! So I hope you have completed the task. Create class and name it what to do. Create a program entry point. Create two variables. One is for storing time, int time, and to begin with, assign it the value of 19. Another variable is boolean for storing the value if the temperature is fine or nasty. It will be a boolean variable. Call it is good weather and assign it true as an initial value. Now let's create a boolean variable which will store the status, if it's late or not. Boolean late. It will be late if the time either equals or more than 23, or if the time is either less or equals 5. So if the time is not yet 5, but later than 23, late will be true. Otherwise, it'll be false. Now let's solve this problem. The first thing to do is to check if it's late or not. Type if late, display the message sleep. As you remember, we mustn't use else this time, so create another condition. Unless it is late, and if the weather is fine, we will go for a walk. And unless it is late and if the weather is nasty, it means we should place an exclamation mark and type is good weather. The construction means unless it's late and if the weather is fine, we will read a book. In this case, the time is 19. It's not late and the weather is fine. If we have written everything correctly, the program must print the message, go for a walk. Run it and see the message, go for a walk. Let's set the time to 3. The program must display sleep. Now let it be day and let the weather be nasty. The program must print read a book. So everything works. You will find the key to the homework assignment attached to our next lesson. See you later.